Okay, in this example, we're going to do a constant rate problem. What's that equation that relates the speed, average speed of a vehicle, the time it's traveling, and the distance? D equals RT. D equals RT. Distance equals rate times time. Yeah, that's going to come in handy here. I'll show you that in a minute. Here we go. Don's Dodge Durango, how's that for alliteration? Don's Dodge Durango travels 1,085 miles. If he had gone 8 miles per hour faster, then the trip would have taken 2 hours less time. Find the average speed of the Durango. Familiar territory? You may not like this territory, but it is familiar, isn't it? What do I usually make to organize my information on these? A good old tic-tac-toe chart. So I think I'll put it over here. On top of it, what do I put? Distance equals rate times time. And then, well, there's two situations, right? So we'll say the actual, what actually happened. And then what if. So I'll label the first row what the actual numbers are, right? And then the what if numbers in the second row. Do you have to use the same labeling? No, whatever you want. Is the trip distance the same either way? So under D, I would just put in 1,085. Okay, what's the speed in the first row under R? What's the speed? Do we know what it is? We could just define it as R, right? And, you could say let R equal the actual speed, and that's in miles per hour, right? MPH. It's always good to keep the units down, or write the units down. And then I'm going to go down to the middle column where you put the X if it's a tic-tac-toe game, right? Always put it in the middle. Okay, that has nothing to do with anything. What would it be, though, in terms of R, if he had actually gone faster? If he had actually gone 8 miles per hour faster, would you add or subtract? Add. There you go. So R plus 8. If you were to do that on the top of the R minus 8. Yeah, and it would work. Yeah. So what he's saying is perfectly fine. If you call this guy R, then this guy has to be 8 bigger than this guy. Oh, so you'd have to subtract the 8 up there. So maybe that's what you were thinking of. Maybe that's how your brain processes this sort of problem, which is fine. But at least to me, it's easy to wrap my mind around that, because then 8 miles per hour faster, the plus corresponds with going faster to me. But whichever way is fine. Okay, what about time? If we called this guy T, so that would mean what? The time, the actual time it takes? And then this guy, if you want to keep this guy in terms of T down here, it's going to actually, going faster, it's going to take less time, so it makes sense to subtract 2. But just like Cameron was saying, what if you didn't, or Ryan, what if you didn't want to do it that way? What if you wanted to call the what if time T? Then what's the other way to set it up? T plus 2. You see it doesn't matter? Okay. But I'll stick with my original way of doing it, just because to me it seems intuitively easier, but that's, everybody's different, and I don't care which way you set it up, as long as it's correct. So you actually have a system of 2 equations, 2 unknowns, don't you? You have 1,085 equals R times T, and you have 1,085 equals R plus 8 times the quantity T minus 2. Now, that's actually, if you wrote it down that way, that'd be a difficult system to kind of wrap your mind around. So oftentimes what's easier in problems like this, since we're just looking for R anyway, the average speed that would correspond to R, wouldn't it? The easier way is to put, okay, time is equal to distance divided by rate, isn't it? If you solve this equation for T, don't you get distance divided by rate? So if you remember to do it that way, it's going to be, you're going to end up with a way easier system, or a way easier equation in the end to solve. So in this case, this little t would be equal to 1085 divided by r, wouldn't it? Everybody see where I got that? Can you do something similar for the second row? What would t minus 2 equal? 1085 divided by r plus 8. Does everybody see that? Stare at that for a minute. And so really what I'm doing then is I'm thinking of this as my system of equations. And the reason it's easier to think of it this way is that top equation is already solved for t, isn't it? And so then it's just a substitution. Plug this guy in here, and then you got everything in terms of r, and you have one equation. Does everybody see that? So I'm going to replace this t with 1085 divided by r. I'm going to subtract this 2, and then we know that that equals this. 1085 divided by r plus 8. It's a rational equation, isn't it? Why would I include a rational equation in a quadratic application section? What's going to happen when I clear the denominators? It's going to turn into a quadratic equation, isn't it? The way to solve this is to multiply through by what? The LCD. Okay, what's the LCD? Okay. So let's multiply both sides by, it's not just r plus 8. What else do I need to throw in there? R. We have to multiply these two denominators together, don't we? So I'm going to multiply the left-hand side by r times r plus 8, and the right-hand side by r times r plus 8. Everybody see that? The right-hand side's easier. Let's do that first. What's going to be left when the smoke settles on the right side? Just this guy and this guy make 1 when you divide, right? And you're left with 1085 times r. Okay, when you distribute this guy, it lands in the numerator here, and then you just distribute it over the minus 2. Nothing goes away. So what do you get for the first term when you distribute? What's going to go away? Put it that way. Whatever this denominator is, it's going to, by design, cancel with the corresponding factor in the numerator of the thing you distribute. Okay, what's left? So r plus 8 times that numerator, right? So I'm going to turn it around and say 1085 times the quantity r plus 8 when you distribute right here. I'm not done distributing, but does that make sense? Now, when you distribute to the minus 2, nothing goes away. So you have the full thing. I'm going to put the minus 2 in front, r times r plus 8. All right, now let me scroll down a little bit, make some room here. Okay, so what do I do from here? What do I have to get rid of? Parentheses. We got to distribute the 1085. First of all, to the r plus 8. So I'll do the first multiplication. 1085 times r is 1085r. You do the second multiplication for me. 8 times 1085, what do you get? You get 8681? Is that what I heard? 8680, okay. That makes more sense, actually. Everybody good with that distribution? Okay, plus or minus 2r. We could do that without a calculator. Distribute the minus 2r. What do we get? Minus 2r squared minus 16r equals 1085r. Whew, all right, not the prettiest thing in the world, but does that make sense to everybody so far? What do I do? Is it a quadratic equation, first of all? Yeah, but I need to simplify, don't I? Okay, so let's simplify. Let's put the negative 2r squared in front. And then we've got to combine 1085r and, oh, wait a minute. Do you see a quick way to do this? Subtract 1085 from both sides. Gone. Nice. So does everybody see why I crossed it out? Just subtract it from both sides. Okay, and then what's left? So minus 16R, and then plus 8680, like that, equals 0. What would be a smart thing to do before you just try factoring or try the quadratic formula? Yeah, you could factor out the -2, or couldn't you just divide the whole thing by -2? So that's how I'm going to think of it. Divide everything by -2, and then the right-hand side just stays 0 when you do that, right? So you get 0 on the right-hand side, then what do you get? R squared minus 8R, or plus 8R. Plus 8R, and then minus, what's 8680 divided by 2? 4,340. Everybody good so far? Maybe that factors, right? But 4,340 is a big number, isn't it? Do you want to mess with it? Nah, I think I'd rather just use the quadratic formula. If it's a small number, if you have small values involved, then factor it. Try factoring it. But maybe it factors. Maybe you could factor it actually pretty quickly. I might get lucky and guess the factors. But the whole point is, now you have another tool at your disposal. You have the quadratic formula. Let's use it. So in this case, R is going to equal negative b plus or minus square root b squared minus 4ac all over 2a. So fill it in. What do we get? I'll go up here. What do we get? What's the opposite of b? Plus or minus square root of 64. Yeah, you just square the b right away. Minus 4ac, so minus what? 4 times 1 times negative 4340. That negative is pretty important, isn't it? Otherwise, you get a negative underneath the radical if you forget to write that negative down, and you get a complex solution, which makes no sense. And you should recognize if you make that mistake, complex number makes no sense. I must have made a mistake. But if you remember that negative on the 4340, it'll turn out to be plus underneath the square root. All over 2a, which is just 2. Okay, so go ahead and take 64. It's going to end up being 64 plus 4 times 4340. Tell me what you get. 17,424? Like that? See if that happens to be a perfect square. Take the square root of it. 132. Okay. So that means because 17,424 is a perfect square, it means it would have factored. But we didn't have to mess with it, and that's fine that we didn't mess with it. So you're telling me you get negative 8 plus or minus 132 all over 2. Does everybody agree with that? Which one are we going to throw out? If you take negative 8 minus 132 and divide by 2, don't you get a negative number? Yeah, so do I really need to compute that? I mean, don't get the wrong idea. Sometimes it makes sense to have negative numbers. If you have negative $150 in your bank account, what does that mean? You're overdrawn by $150. It has a meaning, right? But in this context, for this particular problem, the negative doesn't make sense. But don't always just throw it out. Sometimes it makes sense. Okay. So then we get negative 8 plus 132 over 2. What's negative 8 plus 132? 124 over 2, which is 62. Now, let's take a moment to reflect. Let's go back to Polya's 4 steps of problem solving. And what units is this in? I believe it's miles per hour, right? The 4th step is to ask yourself, is that a reasonable answer? Is Don going to drive his Durango at a negative speed? He's not going backwards, no. So it's positive. First of all, that's good. Is he going to go 1,000 miles per hour in his Dodge Durango? No. And it's not anywhere near 1,000 miles. 62 is a reasonable speed to drive. So yeah, that seems just common sense-wise like it could be a reasonable answer. Now, what else could you do? If you're pretty confident with the equation that you came up with, couldn't you check it by plugging? So this was the equation before I smudged it all up, right? Couldn't you plug back into that and make sure it checks? I'm not going to take the time to do that here, but yeah, you could also do that. But I was really just referring to step 4, pull use 4 steps, check your answer. Does it make common sense? Yeah, that seems reasonable.